learn about the periodic table today. A classification over the elements was first put out by Dmitry Mendeleev in Russia and Lothar Meyer in Germany. They arranged the known elements at that time in increasing order of atomic mass. Because of that, their two classifications were little bit identical. So they noticed that when the elements are arranged in the increasing order of atomic mass, physical and chemical similarities can be seen between these elements. Right? But in the modern periodic table that we use now is made considering the atomic number. We have arranged these elements in the increasing order of atomic number. You can see here Lothar Meyer and Dmitry Mendeleev, the first persons to put out a classification over the elements. We will not call it a periodic table, we will just name it as a classification of elements. Here you can see the modern periodic table. This modern periodic table has groups downwards and periods like this. Rows were known as periods and the columns were known as groups. Elements were put into groups considering their valency. So if we consider hydrogen, lithium, sodium, which belongs to the same group of periodic table, we will write their configurations to see the similarity. 1s1 configuration for hydrogen, 1s2, 2s1 configuration for lithium, 1s2, 2s2, 2p6, 3s1 configuration for sodium. You can see their valencies here. 1 is 1, 2 is 1, 3 is 1. We can write a common valency as n is 1 representing this. N is 1 means n represent the principal quantum number. So n is 1 valency having elements are in group 1. All the n is 1 configuration having elements are in group 1. In the same way, all the groups arranged like that except helium. Helium has ns2 valency but it is in group 18. Normally ns2 valency containing elements are in second period but helium is in 18th one. Reason for that is all the possible number of electrons that can be possessed by helium are already owned by helium. Helium can have 2 electrons. 2 electrons are already filled. So it is considered as a noble gas or an inert gas. Noble or inert gases are put into 18 group. So it is in the 18th group. Moving on to the periods. Periods were given to elements considering their number of energy levels. Hydrogen and helium has only one energy level. So that is in period 1. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, all of them has 2 energy levels. So they are in the second period. Same way follows downwards. And you should remember something. This period we call like these periods. These periods show some property variations of elements. Right? Some properties of elements vary along the periods. We call them as periodic trends. We can learn it in future, but just remember that along the periods, periodic trends are shown. Periodic trends are shown along the periods. You have to learn them in near future. Groups in the modern periodic table has names. That means group 1 elements are known as alkali metals. Group 2 elements are known as alkaline earth metals. And group 18 elements are known as noble gases or rare gases. Then group 16 and 17 also have different names. Group 16 elements are known as chalcogen. We call them as chalcogen. Halogens are in group 17. Here group 17 they are known as halogens. So these are some special names given to some groups in the periodic table. If I go on it again, group 1 alkali metals, group 2 alkaline earth metals, group 16 chalcogons, group 17 halogens, group 18 noble gases or rare gases. We will learn the way of numbering the groups of the periodic table. Here you can see 1A, 2A, 3A, 4A, 5A like numbers are given to the groups in the periodic table. But you can see here this order is complex, right? See here 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. 1B is here, 2B is here, 3B is here. Likewise, 8, 9, 10, these three have 8B. So this way is little bit confusing and complex, but just remember that one also. After this method, then came these Roman numbers were replaced by Arabic numbers. That means instead of writing 8A in this way, 8A was written in this way. Same confusion again. To eliminate this confusion, IUPAC introduced a numbering system to this periodic table. IUPAC means International Union of Pure and Applied Chemistry. So here they gave the normal method. It is easy for us. 1, 2, 3, 4, 5, 6, 7 like. The groups were named from 1 to 18 by IUPAS, International Union of Pure and Applied Chemistry. Here is a summary of the lesson that we discussed now. And now we are going to move for the classification of periodic table into 4 blocks based on the filling order. So elements in the periodic table can be divided into 4 blocks as S block, P block, D block and F block. If the electrons of an atom, the last electrons of an atom enters to a s orbital, then it is known as s block element. In the same way, if the last electrons of an atom enters to a p orbital, then it is known as p block element. If the last electrons of an atom enters to a d orbital, then it is known as d block element. If the last electrons of an atom enters to a f orbital, then it is known as f block elements. Group 1 and 2 elements are s block elements. In the previous part, we discussed that group 1 and 2 has NS1 and NS2 common valency. So, by that we know that NS1 and NS2, that means last electrons fill to s orbitals. Then, group 1 and 2 are s block elements. And in the same way, group 13 to 18 p block elements are there. You can see they are named as 3A to 8A p block elements, and 3B to 2B d block elements, and here you can see in green color F block elements. F block elements are lanthanoid and acetinoid series. That means there is a series of F block elements. This series is somewhat lengthier. If we put this series inside to this, the periodic table becomes more lengthier. Because of that, it is extracted here. These two are lengthy, but it is extracted here. This is F block elements. They are known as acetinoid and lanthanoid series. We know that maximum possible number of electrons in S subshell is 2. Right? In the same way, maximum possible number of electrons in P subshell is 6. By using this maximum number of electrons, we can get a clue about groups in the periodic table belong to that block. I will give it to you like this. We know that S block elements are in group 1 and 2, right? S block elements are contained in group 1 and 2 only. So how many groups? 2 groups. And how much is the maximum possible number of electrons that can be in the S block? 2. Then that is the way. In the P block, here 13 to 18. 6 groups are there, we know that maximum possible number of electrons in P subshell is 6. In the same way, here you can see F block. There are 14 possible number of electrons and as well as 14 groups. Here this way 10, you can see here 10 groups are there for D block as well. So maximum possible number of electrons in a particular subshell is equal to maximum number of groups, that means all the number of groups in the periodic table which belong to that block, right? Different names given to these block elements, right? No specific name is given to S block elements. P block elements are called representative elements or main group elements, and D block elements are known as transition metals, and F block metals are known as inner transition metals. Remember these terms because questions can be asked with the use of these special terms for groups. So that is the end of the lesson today. Thank you for being with me till the end.